Hi AP Stats. Today we're just going to do a quick review of lesson 9.1 day 2. And the learning target for this lesson is that you should be able to interpret a type 1 error and a type 2 error in context. Once you have them interpreted, you should be able to give a consequent of each error in a given setting. So let's take a look at this. This actually is based on something that actually happened on the west side of the state. So the Wolverine Worldwide, a shoe company in Rockford, improperly disposed of chemicals, PFAs, which have linked it to the groundwater. The state of Michigan says that if more than 7% of the households in a city exceed the safe limit, the city needs to switch to bottled water. A concerned citizen takes a random sample of 100 households and finds that 12 have unsafe water. Do the data provide convincing evidence that Rockford should switch to bottled water? Now you can pause this and try to go through and see if you can answer some of these questions. When you get stuck, come back and let's see how you did. Okay, so state appropriate hypotheses for performing a significance test, and we're going to use a significance level of 5%. Okay, so they have to switch to bottled water if more than 7% of the households in a city exceed the safe limit. So we're going to start with the null hypothesis that P, the true proportion of households in Rockford with unsafe water, is only 7%. The alternative hypothesis would be that P is greater than 7%. That's when they're going to say, okay, we now are at the unsafe level for the city and have to switch. So P is the true proportion of households in Rockford with unsafe water. All right, after conducting a significance test, the p-value is 0.025 is found. Interpret this value. Again, p-value is the probability that your sample data occurred given that the null hypothesis is true. So we're going to assume that our null hypothesis is true, that p is equal to 0.07. There is going to be a 0.025 probability of getting a sample proportion of 0.12 or greater purely by chance. Again, we say or greater because we always take it in the direction of the alternative hypothesis. So based on the p-value, should Rockford keep the current water or switch to the bottled water? So our p-value is less than our significance level, so that means we should reject our null hypothesis. If we go up here, we should be rejecting that p is equal to 0.07. So we're going to have convincing evidence that the true proportion of households is greater than 7%. And if that's the case, we're going to need to switch to bottled water. Okay, so let's suppose this decision is wrong. Okay, what would be the consequence of this error? Okay, so let's say this was the wrong decision, that we switched to bottled water. Well, a consequence of this error would be spending a lot of money purchasing bottled water when we didn't need it. This here is going to be an example of a type 1 error. That's when your null hypothesis is true, but you reject the null hypothesis. Okay. Okay, so let's take here. If the water is safe, what is the probability that this error will occur? Well, if the water is safe and we actually reject it as being safe, this is going to occur 5% of the time. Because 5% of the time we get a statistically significant result, which means it's unlikely to happen by chance, purely by chance. So our type 1 error is going to occur whatever our significance level is. That's how often the type 1 error will occur. Okay. So now, suppose the p-value is 0.217. In this case, would the city keep the current water or switch to bottled water? Well, our p-value 0.217 is greater than our significance level, so we're going to fail to reject HO. We don't have convincing evidence against HO. So if we don't have convincing evidence against it, we're going to keep the water. But let's suppose the decision is wrong. Okay, we make this decision to fail to reject the null hypothesis. Okay, so that means we're going to keep the water. Well, what if that's the wrong decision? What would be the consequence of this error? Many people would drink unsafe water and could get sick and even die. Of the consequences in 2 or 3, which one is more serious? Obviously, number 3, people would get very sick which is much worse than wasting money. Okay, so here are the main ideas. We're going to take a look at the truths and we're going to compare it to the conclusion. Our truths can be that the null hypothesis is true or that the alternative hypothesis is true. Our conclusions can either be to reject or fail to reject the null hypothesis. Well, if our null hypothesis is true and we reject it, that is a type 1 error. Now, if our evidence shows us that the alternative hypothesis is true, that the evidence is going against the null hypothesis, and it's supporting our alternative hypothesis, we would reject the null hypothesis, and that's what we want to do. So that's why we have the smiley face there. If our null hypothesis is true, then we fail to reject the null hypothesis. Well, that's correct. Okay? But if our alternative hypothesis is true, okay, the evidence is going against the null hypothesis, so it's showing our alternative hypothesis appears to be true, but we failed to reject that null hypothesis even though the evidence is against it, that is a type 2 error. So what's really important for this lesson is you have to understand what a type 1 error is and what a type 2 error is. You have to sit down and learn what they are and then be able to apply it in context. So type 1, you need to know that the null hypothesis is true, but you make the error and reject it. So the null hypothesis is true, but you made the wrong decision. The probability that that's going to happen will be equal to your significance level, okay? Because we reject the null hypothesis when our p-value is less than our significance level. Type 2 error, our alternative hypothesis is true, but we fail to reject the null hypothesis. So the alternative hypothesis is true, but we made the wrong decision. Okay, so you can pause this and try to check understanding and check back to see how you did. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after placing an order. Based on the store records, the proportion of customers who had to wait longer than 2 minutes was 6.63. To reduce this proportion, the manager assigns an additional employee to drive-through orders. During the next month, the manager collects a random sample of 250 drive-through times and finds that the sample proportion is 0.576. He then performs a test of the following hypotheses at a 10% significance level, where P is the true proportion of drive-through customers. So here are our hypotheses. Okay, it's the true proportion of drive-through customers that have to wait longer than 2 minutes. So the null hypothesis is that the true proportion that have to wait longer than 2 minutes is 63%. The alternative hypothesis is that this new employee should make the percentage of customers who wait less than 2 minutes, who wait more than 2 minutes, less than 63%. So describe a type 1 error and describe a type 2 error in the setting. So a type 1 error is where we reject the null hypothesis even though the null hypothesis is true. So if our null hypothesis is true, that means 63% of customers wait longer than 2 minutes. But he's going to reject that. That means if he's rejecting it, he finds evidence against it. But the manager finds convincing evidence that the additional employee actually reduced this proportion. So that would be a type 1 error. A type 2 error is when your alternative hypothesis is true, but you fail to reject the null hypothesis. So if our alternative hypothesis is true, the P is less than 0.63, that means less than 63% of the customers wait longer than 2 minutes, but he doesn't find evidence to support that, so he's going to fail to reject the null hypothesis. So the manager does not find convincing evidence that this additional employee reduced that proportion. Okay, so he failed to, his evidence didn't back that up, so he failed to reject the null hypothesis. So which type of error is more serious in this case? Justify your answer. My opinion, I wrote, is type 1 error is more serious. okay? Type 1 error is what's going to happen here is the customers are actually waiting longer than 2 minutes, but he thinks that additional employee is reducing this this time, the time that they wait. Well, he's spending more money on an extra employee, believing it reduces the proportion of customers who wait, but it's really not happening. Now, some students might argue and say type 2. They might say that type 2 because he might fire the employee since he did not find evidence that the employee is reducing the proportion of customers who wait longer than 2 minutes. Okay, so even though the wait time was actually, or the number of customers who were waiting more than 2 minutes was going down, he didn't find that evidence that the employee was actually helping, so he might fire him. And the last part, based on your answer to question 2, do you agree with the company's choice of a significance level of 10%? Okay, well, I chose type 1 error. And one of the things we know is that a type 1 error will occur equal the percentage of whatever our significance level is, okay? Because of the fact the HO is true, but we reject the HO, and we reject the null hypothesis when our p-value is less than our significance level. So in this case, we're going to reject the null hypothesis at 10%. So the type 1 error is going to be equal to 10%. So would I want to keep the significance level at 10% in case of a type 1 error? No, I would rather not. I'd actually like to lower the percentage of making that type 1 error. So if the null is true and we fail to reject it, this is a type 1 error, which will occur 10% of the time just by chance. So the company should lower the significance level. If they lower it to 5%, type 1 error would only occur 5% of the time. If you said type 2 error is more serious, then you would want to increase your significance level. So not a lot to this lesson, but it is definitely going to be something that you have to understand, type 1 and type 2. You're also going to have to be able to think logically and critically about those definitions and how to apply it to context. Okay, have a great night.